In this lecture, we're going to learn about sizes of class objects and try to think about it. What are we going to see if we try to print the size of our class here called wrapper? Inside we have two member variables which are of int type, and we have a member variable which is of std string type. What do you think we'll see when we print the size of this wrapper object here? Try to think about it. So what C++ does, it's going to only account for the size of your member variables. So it's going to add the sizes of these guys in memory. So we know an int is going to take 4 bytes in memory. So we're going to have 8 bytes for these two ints. And we're going to have an unspecified amount of memory for a string because a string is internally implemented as a class and it stores its data as const char pointers. So we have really a pointer, and the size of an object doesn't really account for things you are referring to using pointers. It may count the size of the pointer itself, but it's not going to count what is pointed to. And in the case of string, for example, we really want to know the range of things that we are pointing to. So we're not going to have correct information with std string here. But in general, the size of an object is going to be the sum of the sizes of its member variables. The functions are not going to be counted then. The functions are just helper functions that live somewhere in memory, but they're not going to be accounted for in the size of your object. Another reason you might think functions are not accounted for in the size of the object is that really functions are affiliated with the class itself. Functions are not affiliated with class objects. The class is going to be the blueprint from which we're going to generate thousands of objects if we want, but the functions or the methods are going to be associated to the blueprint itself. So it really wouldn't make sense to associate the size of those functions in memory to class objects. Now that you have this idea, let's head over to Visual Studio Code and play with this a little more. Okay, we have said that the size is mostly going to be the sum of the sizes for the member variables, but this is not always correct because of a phenomenon we called boundary alignment. Boundary alignment is a thing most compilers do when they have member variables of different types. And member variables that have the size of 4 bytes in memory are going to be stored at memory locations that are multiples of 4. And because of this phenomenon, we might have gaps between our memory if we have variables, for example, that are of 2 bytes in memory and 4 bytes in memory. And we're going to have gaps inside, and the size of the object is going to be slightly off the sum we might do for the sizes of our object. I realize this may be confusing. We're going to head over to Visual Studio Code and we're going to see a few examples. Okay, here we are in our working folder. The current project is size of class objects. We're going to grab our template files pretty quick and we're going to put them in place. And we're going to open our project in Visual Studio Code by dragging and dropping here. We have our main CPP file. We can close the left sidebar and we can clean the main function here. We're going to set up a simple class. Let's call this dog. Why not? We have been using dog, so let's use this again. We're going to put our closing semicolon. We're going to put a public section and it's going to just contain a constructor, and we're going to say dog, and we're going to use the default, and we're going to put in a private section, and in here we're going to put in a size t and say this is the leg count of a dog. Why not? Let's say we are modeling this. Okay, so now we have our dog class in place. We can create objects of this dog class. We're going to say dog1. And if we do this, we are interested in knowing the size of our dog class here. So we are going to say stdcout size of dog, can say that, and fingers crossed we're going to see the size of our dog object here, and try to guess what we're going to get. In the slides we have seen that the size is mostly going to be the sum of the size of the member variables. And let's print the size of size t here because size t is our only member variable, so I think it's going to be helpful to see its size printed out. So we're going to have some context if we do that. We're going to say size of size t, and we're going to Save that. And we're going to build this program. Let's do that. We're going to pass this through GCC. You see the build is good. And we're going to bring up a terminal and run this. See what happens. Okay, we see size of size t is 8 and the size of our dog object is 8. And this is really cool because we see that the size of our class object is really the size of our member variables that we have in here. Let's set up another member variable and really show you this. So we're going to have arm count. Okay, so we are just messing with this to learn. I don't aim for this class here to make some sense practically. We just want to see how the member variables affect the size of our class object. Now we have two member variables in. We're going to try and build. We're going to use GCC to do that. And we're going to clear and run Rooster. Now you see that size of dog is 16. And this is really proving that the size of an object is only accounting for the sizes of the member variables. It's not going to count the functions that we have here. So if, for example, we had a function that says printful and we have another one that says do something, this is not going to change the size of our object because functions aren't accounted for in the size of our object here. So let's build and really show you this. The build is good. We can clear and run Rooster. We see that we have the same sizes. The size of dog is 16. The size of size t is 8. We can even use object names here. For example, we are using the class itself, but we can use dog1 here and we're going to get the same information. Let's build and we're going to clear and run Rooster. And you see that we have the same size. So if we change this thing to put in a pointer, we're going to see something else. Let's put in an int pointer and let's say ph, like we have been doing all along, and see what we get. And we know that the size of a pointer on my system, let's print that out so that we have no doubt. Let's, for example, say size of int pointer is going to be size of int pointer. Okay, let's build. We're going to pass this through GCC, and the build is going to be good. We can clear and run Rooster. We're going to see that we have 24 because we have two member variables that are going to be 8 bytes in memory of size t. They are of type size t, and we have a pointer which is going to have a size of 8 in memory. But we don't care what this pointer is pointing to. If, for example, this pointer is pointing to something really large, we don't care. We're just going to account for the int pointer here. And this is really phenomenal because if, for example, we try to set up an std string object, and by now you should know that std string itself is implemented as a class in C++. So it's really a class and we can print its size. So let's set up a string object here. We're going to say std string and we're going to say name and we're going to initialize this with hello world. Okay, we're going to see something really strange here. So if we print the size of name here, we're going to say size of name and we're going to print that. Let's see what we get. We're going to run and we're going to see the build is good. And can clear and run Rooster. We're going to see that size of name is 32. Let's change the text inside our string and see that we change accordingly because this can really be confusing. Let's say I am the king of the universe. Why not? And we're going to build again. Let's see what we get. Fingers crossed. This is going to blow your mind. You see, we have the same size for name even if we are changing the text in here. So what is really happening? The string is storing our text here as a const char pointer. And what we have is a pointer inside. And what we probably have inside is a member variable, which is a pointer like we have here. So what we will be accounting for in the string class is the size of the pointer, but it's not the size of what is pointed to. Okay, so the char pointer may be pointing to thousands of characters in memory, but as long as the compiler is concerned, it's just going to use the pointer member variable and it's going to account for it in the size of your object. Hopefully you can understand why the size of our string object is going to be the same regardless of how large is the string. And this is really something you need to understand. Otherwise, this is going to throw you off as you design your C++ applications. And this is really all I had to share in this lecture. The size of your object is mostly going to be determined by the member variables you have, and the size is going to be the sum of the sizes of your member variables. We are going to stop here in this lecture. In the next one, we're going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.